Assalamualaikum warahmatullahi wabarakatuh. My name is SITI NURAIN. Today, my group and I will present about question A and E for advanced assignment. Before we go to the question, so I would like to do an introduction about transfer function and dot plot. Transfer function can be defined as ratio of Laplace transform of output to the Laplace transform of input when all the initial conditions are assumed to be zero. The transfer function h omega of a circuit is the frequency-dependent ratio of a phasor output y omega to a phasor x omega. Y omega is an element voltage of current and x omega is a source voltage of current. Looking at the block diagram, transfer function determine whether the frequency allows the voltage and the current to go through. Look at the equation where h omega equal to y omega per x omega. In this equation, x omega, we can define it as input signal to the system in the frequency domain, and y omega is the output signal from the system in the frequency domain. Based on the equation, h omega also can be expressed in terms of its magnitude and phase. It represents the magnitude response of the system, which shows how the amplitude of the input signal is scaled by the system at each frequency. Phase represents the phase response of the system, which shows how the phase of the input signal is shifted by the system at each frequency. Frequency response of the circuit can be obtained by plotting the magnitude and phase of the transfer function. H omega can be expressed as a ratio of two polynomials where h omega equal to n omega per d omega. N omega is the numerator polynomial of the transfer function. It represents the roots of or zero of the transfer function, and roots of n omega are the frequency at which the output of the system is zero for a given input. D omega is the denominator polynomial of the transfer function. It represents the poles of the transfer function. Roots of d omega are the frequency at which the system response becomes infinite, indicating resonant frequency or system instability points. Dot plots are similar plots of the magnitude in decibel and phase in degree of a transfer function versus frequency. There is four combinations in transfer function h omega. First, a gain k. Second, a pole or zero. Third, a simple pole or zero. And four is a quadratic pole or zero.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad IZZAT bin TAJUDDIN. My number metric is B1123138. Today I want to present about the question transfer function A. Okay, the question is h omega equal to 100j omega divide j omega plus 2 j omega plus 10. Go to how to get. What we do, firstly, to transfer function to dot plot. Now we need to change from general form to standard form. H omega equal to 100j omega divide j omega plus 2 j omega plus 10 is a general form. The standard form is a 200s divide s plus 2 s plus 10. How to convert? Firstly, j omega equal s, need to change to j omega, this one. All j omega need to change to s. First step. Second step, need to factorize. After factorize, you can get h omega 10 j omega divide j omega divide 2 plus 1 multiply j omega divide 10 plus 1. After get the answer, need to change to HDB, is a decibel scale or properties of logarithm. 20 log 10 plus 20 log 10 j omega minus 20 log 10 j omega 2 plus 1 minus 20 log 10 j omega 10 plus 1. After that get equation, need to plot the graph. The graph, my members can explain. Next slide.
Okay, now we're gonna move to the next part. That it is the result graph, which is magnitude graph and phase graph. So first, the magnitude graph, as you can see on the slide, the graph that I've made before, which is the, at first we sketch the x and y axis, and I didn't write the x plot and y axis, which is the x axis is for omega, while the y axis is for HDB. So the blue line, the blue line for line graph as shown in the table notes. So we plot the blue line using the table. Okay, first we sketch the blue line. After the sketch the y-axis and x-axis, we plot the graph, which is the with the number, and then after that we're gonna do the next part, that it was using the notes from the table. The first line is there at the 20, while the second line is there at the minus negative, but is increasing about 45 degree above, and for the third line it's decreasing about 270 something degree. Also the last one, for the fourth plot, we just parallel, not parallel, but the value of the plot is there, where it's almost the same with the third one, but it's beside it. So it's gonna plot like that as shown as from the table. So after we get the line graph from the value from the table, so we just plot the graph as per shown. I'm using a red line to plot the graph. So it starts from the 0 and above 20, then it's decreasing to more than minus negative 20. Okay, the next part is phase graph. So as you can see, I've already sketched the graph a little bit, so I will continue it in the video. From the slide, as you can see at the above, from the calculation we're gonna get the value for the plot, and then we compare the value from the plot. We compare it with the table, so we're gonna get the line graph from the table. I'm using the color for the line table, one color from one line table. So, and then after we plot the line graph, then we're gonna get the phase graph in the video. So I will show it how.
Hi, I'm gonna explain about how to derive transfer function from the plot given. As you can see in the slide, the concept is when the slope increase by positive 20 dB over decade, the zero is present, while when slope is decreased by negative 20 dB over decade, the pole is present, and when slope is decreased by negative 40 dB over decade, the pole is present. Okay, first, on the first corner frequency, you can see that omega equal to 5 radian per second, which slope going to change from 0 to positive 20 dB over decade. Slope is added positive 20 dB over decade, and 0 is exists at omega equal to 5, which the equation will be 1 plus s over 5 in num. On second corner frequency, as you can see, omega is equal to 10 radian per second. Slope changing from 0 dB over decade to negative 20 dB over decade. Slope is added at omega equal to 10 radian per second, which means simple pole exists. For the third corner frequency, omega equal to 100 radian per second, and the slope changing from 0 dB over decade to negative 40 dB over decade. And it shows when negative 40 dB over decade slope is added, and the simple pole exists at omega 100 radian per second.
So I'm going to continue. To find a value of k, we use formula 20 log 10 k plus minus slope of first line log omega equal to gain. When we look at the graph, the slope of first line is 0. So 20 log 10 k plus 0 log 10 5 equal to 20. 20 log 10 k plus 0 equal to 20, and we got the value of k, which is k is equal to 10. Now we solve first corner frequency, second and third corner frequency in HS equation. We will get 20,000 k s plus 5 per s plus 10 s plus 100 square. Then we multiply 2000 with k value that we got, which is 10, and then we got 200k s plus 5 per s plus 10 s plus 100 square.
In this discussion about the bot plot, first, the bot plot is a graphical representation of a system frequency response. The frequency is plotted logarit on the x-axis. It provides insight into how a different frequency. Next, this discussion about the transfer function. First, in control theory and signal processing, transfer function is a mathematical representation of system response input. It is usually denoted as Hs, is the Laplace transform variable. The transfer function can be derived from the system differential equation or obtained experiment.
For the conclusion is a bot plot consists of two plots where one showing the magnitude response and the other ones showing the phase response of the system over a range frequencies. A transfer function relates the Laplace transform of the output signal to the Laplace transform of input signal. In summary, bot plot provides a visual representation of the frequency response of a system, while a transfer function a way to understand how the system behave in a response to different inputs. Thank you.